All right, in problem 2, we have the functions f and g graphed here, and here are their equations, and we have region R here and region S here. So part A, we have to find the sum of the areas of regions R and S. We want to figure out what these two areas add up to. First, you want to figure out what function is which equation, which one is which. So I use my graphing calculator just to ensure, and you can see that the red function here, that's your x to the fourth one, so that'll be your g. So this will be g up here, it'll be g over here, and this will be f. Now, to figure out the area for R and S, we want to figure out this point of intersection and then add this area to this area. So for this first region up to here, we're going to have the integral, well, I'll just write it up here. We'll have the integral of g of x minus f of x. So g minus f dx plus the integral of f of x minus g of x. And I'm just doing some shorthand just so you can get the idea. On your test, make sure you write it really nicely. So that's the idea. We need to figure out where they intersect. So we would go from 0 to whatever that point is and stop at 2. So on the graphing calculator, you can find it by using this stuff, using this technology, lower bound. They intersect at 1.0328. So this point will be 1.0328 for x. And if you want to write y, it's 2.4011. So we would write this integral as the integral from 0 to 1.0328. And then here, 1.0328. Now use your calculator to figure out this. So we can just go into our calculation screen. Oops. Zero. I just want to make sure we type this correctly. All right, and then zooming ahead, you'll get right about above 2 if you did it correctly. I feel like sometimes the hardest part is typing it in correctly. But you should get about 2.00434. That's good enough. Okay, part B. Region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. So this will be like the side of the square from here to here. Find the volume. So what's going on here is that you have a square where the side lengths are this length, which is going to be f minus g. So this is f minus g from here to here, and then that means this is f minus g. So the area of this square will be just f minus g squared. And you're going to set up an integral from this point to 2. So your integral is going to be, I'm just going to put it over here again, just to, you can see the whole thing. So it'll be from 1.0328 to 2, where you got f of x minus g of x squared dx. So let's run that in their calculator. Okay, if you did that correctly, you'll get about 1.28. All right, in part H, or part C, let H be the vertical distance between the graphs F and G in this region. So let's say this length is H. Find the rate at which H changes with respect to X when X is 1.8. So what you're basically doing is finding the derivative of H and then plugging in 1.8. So you're going to have that H of X is going to be equal to F of X minus G of X. And if you want to find the derivative, you just take H prime of X minus F prime of X minus G prime of X, and you evaluate it at 1.8 for that specific point. So let's run this in our calculator too. All right, if you do that correctly, you'll get about negative 3.811. So then that'll be your answers. All right, so I hope that helps. Make sure you check out the next free response problem in this exam.